If switching how your romaine is watered could cut illness by over 96%, would you demand that change before the next salad reaches your plate?
Welcome to Dr. Mercola's Cellular Wisdom. Stay informed with quick, easy-to-listen summaries of our latest articles, perfect for when you're on the go. No reading required. Subscribe for free at mercola.com for the latest health insights.
Hello, and welcome to Dr. Mercola's Cellular Wisdom. I'm Ethan Foster. Today we're looking at why romaine lettuce keeps showing up in E. coli, O157:H7 outbreaks, what the latest modeling reveals about irrigation as the decisive risk, and what you can do at home to reduce exposure.
I'm Alara Skye. We'll stay focused on confirmed findings. You'll hear what the Cornell team uncovered from field to table, why post-harvest fixes only go so far, how concentrated animal feeding operations factor in, and the specific steps you can take immediately, without adding claims beyond the evidence.
In November 2024, romaine was confirmed as the source of an outbreak spanning 15 states. At least 89 people became ill, over a third were hospitalized, and one person died. Regulatory details remained limited, even as contaminated lettuce had already entered homes. Recurrent events like this are why researchers mapped how contamination actually moves through the supply chain.
The study in Scientific Reports simulated romaine's journey from irrigation to harvest, processing, storage, retail, and consumer handling. Running the model 100,000 times exposed, which variables matter most. Baseline risk was small but important. About 1% of batches carried E. coli O157:H7, and a single batch represents more than 2,000 plants, enough to seed widespread illness when contamination occurs.
Irrigation practices dominated the risk profile. Overhead application of untreated surface water produced the highest contamination and the heaviest bacterial loads. Nearly 0.5% of those batches were contaminated under that scenario. When contamination happened under overhead spray, levels often exceeded what's needed to cause illness.
Changing how water reaches the crop altered outcomes dramatically. Shifting from overhead sprinklers to furrow irrigation cut modeled illness by 96.3%, and drip irrigation achieved a similar reduction. Treating surface water also helped. Chlorine cut illness about 90%, ultraviolet light about 91%, and peracetic acid nearly 97%. By contrast, consumer washing lowered risk only 28%, and colder retail storage reduced it 17.1%.
Even stronger plant-scale washes, those that kill 2 to 3 times more bacteria, were projected to reduce illness 61.9 to 98.4%. In a best-case laboratory scenario, where a wash removed nearly all bacteria, illness fell by 99.7%. These aggressive interventions are not industry standard. They also rely on chemicals such as chlorine, which carry documented long-term risks. The core message from the study is clear. Preventing contamination in the field matters most.
There's another upstream driver you need to know: the proximity of concentrated animal feeding operations. Outbreaks linked to leafy greens grown in the Salinas and Yuma regions since 2018 have repeatedly occurred near large feedlots. That pattern is reinforced by environmental sampling, showing Shiga toxin-producing E. coli appearing in water, soil, sediments, plant tissue, and even air and dust around fields.
Airborne dust from adjacent feedlots has been shown to settle into irrigation canals, increasing pathogen prevalence downstream even without surface runoff. The farther you move from the feedlot source, the fewer positive air samples appear. Wildlife in these regions were not identified as the primary carriers of O157:H7. Nearby cattle operations were the consistent contributors. This helps explain why lettuce remains vulnerable when grown next to industrial facilities.
The implication is direct. If irrigation pulls from canals influenced by dust from feedlots, overhead spraying can deposit pathogens onto leaves that are eaten raw. Once organisms are on the leaf surface, downstream steps can only reduce, not eliminate, risk. Prevention means using cleaner sources, treating water, and prioritizing furrow or drip delivery instead of overhead spray.
While farm-level changes are the real fix, you still have practical ways to cut risk at home. Start by monitoring recalls and outbreak notices from the FDA and CDC. When lettuce is recalled, treat the alert seriously. Contaminated product can remain on shelves. If a recall hits Romaine, the prudent choice is to avoid that product line until the advisory clears.
Choose whole heads instead of pre-cut or bagged greens. Cutting increases surface area and mixing multiplies cross-contamination risk. One tainted source can affect an entire batch. The same logic applies to fruit. Pick whole items rather than pre-cut trays whenever possible.
Shorten time and handling by buying locally when you can. Produce that spends less time in transit, and storage tends to carry a lower microbial load by the time it reaches you. Farmers markets often reduce the number of handling steps where pathogens can spread.
Tighten hygiene. Wash your hands with warm, soapy water before and after handling produce. Use separate cutting boards for produce and raw meats, and sanitize knives and counters after preparing raw animal products. Store lettuce away from raw meats, ideally on shelves above them, to prevent drips and cross-contamination.
Wash produce correctly. Rinse under cool running water and gently rub each leaf. Do not wash lettuce before storage because moisture accelerates spoilage. Avoid using water more than 10 degrees colder than the produce, since that gradient can draw microbes inside through natural openings. Refrigerate promptly at 40 degrees Fahrenheit, that's 4 degrees Celsius, or below.
If you also want to reduce chemical residues, a baking soda soak is the most effective option referenced, outperforming bleach solutions while remaining safe when followed by a rinse under running water. This step reduces both pesticide residues and surface bacteria. Use it just before eating, not before storing.
Adjust serving methods for higher-risk family members. For young children, pregnant women, the elderly, and anyone with weakened immunity, lightly cooking greens can add a margin of safety by destroying pathogens. Lettuce isn't commonly cooked, but adding it to soups or quick sautés is a practical alternative during an outbreak.
Some quick answers to frequent questions. E. coli O157:H7 is dangerous because it produces Shiga toxins that can damage your intestines and kidneys, leading to severe diarrhea, abdominal cramps, kidney failure, and sometimes death. Romaine keeps appearing in outbreaks because it's often irrigated with untreated surface water delivered overhead, and nearby cattle operations can contribute pathogens to that water and the surrounding environment. Washing at home helps, but only by about 28%, which is why prevention before harvest is essential.
Here's your challenge for this week. Audit how lettuce gets to your plate. Check for any current recalls. Choose whole heads over bagged. Buy from a local source if available. Wash correctly just before eating. Keep storage at or below 40 degrees Fahrenheit. And use a baking soda soak when you're ready to serve. If someone in your home is at higher risk, cook greens until the outbreak window passes. Thank you for watching Dr. Mercola's Cellular Wisdom. We'll see you on the next episode.
Thanks for watching. Subscribe now and click the notification bell so you never miss an update. See you in the next video.